Hello everyone. The title of today's lecture is Decimal Representation of Real Numbers and it's a part 2. If you can see here, today I have just marked some decimal representation of real numbers. I will try to use these decimal representations and convert these numbers into some rational numbers, appropriate rational numbers. So let's start today's lecture. If you see this first decimal representation, it's a string of threes. What it is? It is a string of threes. The number 3 is repeating. If you see here in the second number, only 2 digits are repeating. This 3, 5 are repeating. Fine. And if you see in the last, it's a decimal representation which is of course finite, and in this no digits are repeating. After this it terminated. So now the quick observations which we can make: the first two decimal representations are non-terminating, and of course they are infinite non-terminating decimal representations. In the first one only one digit is repeating, whereas in the second two digits are repeating. In third it is a non-terminating decimal representation. My task for today is to reduce these decimal representations into the form P by Q. Of course, they are again P and Q are integers. Fine. So what we are interested in reducing the given decimal representation in the form of this ratio P by Q, where P and Q are integers and Q is non-zero. Now let's first try to consider the first case. So now I can reduce. We understood what is our task for today. Consider this number. Since I don't know what is this decimal quantity is, so let me call it, suppose the variable I give a name x. So my x is 0.3, this decimal representation, and here these three ellipses means this string of threes. This is what string of threes goes forever in a similar fashion. Now what we have observed that only 3 is repeating, only one digit is repeating. So if I call this equation 1, I have to multiply this equation by 10. After multiplication we get 10x and 10 times this quantity. Since if you multiply it by 10, then of course this decimal will shift one place to the right and you will get 3.3333, and this will continue, and here it is 10x. Okay. Now if you observe, we can easily rewrite this quantity, this as 3 plus this decimal 0.3333 and so on. Fine, because if you sum this is the resulting decimal. Here is 10x, and from equation 1 we know this is x, so this can be replaced by x. Over this quantity I can rewrite x using equation 1. Here it is 10x. Now it's a linear equation in one variable x, and I can easily solve it. So it is simply 10x minus x, that is I am collecting the like terms on the one left side. Like terms are x, and this is a constant, so I am collecting the like terms one side and the constant on the other side. So what I get from here, 9x equals to 3, or my x is simply 3 by 9, which is 1 by, if you cancel the common factor 3. So this decimal expansion, if now I rub this, so this decimal expansion 0.3333 and so on has a value of 1 by 3. This is the required fraction we got. We can use a similar approach to calculate these two. If you observe here in the second case, two digits are repeating. So what we will do in the next case, if again I consider it to be equals to x 0.23535 and so on. So because two digits are repeating, so I will multiply this equation again, if I call it 1 by 10 raised to the power 2. By what I am going to multiply? 10 raised to the power 2. So we will multiply equation 1 by 10 raised to the power 2. So I will multiply this equation by 10 raised to the power 2 because the number of here the exponent will be the number of digits repeating. So it is simply 100. So multiply on the both sides 100x equals, if I multiply it by 100, what we get? Then now the decimal will shift 2 places to the right because we are multiplying by 100. So what we are going to get? 23.535355 like this. Now what we are interested in, to get this on the right hand side of the last equation. So what I am going to do, if on the rough, I will make a rough calculation, and if I subtract this part from this, what I have 23.53535 and like this one, and here we have 0.23535 and so on. So basically, if you see, if I calculate the difference, what I am going to get, the 23 will come as it is, and from here these all will cancel, so certainly they are 0, and from here 3. It doesn't matter whether you write string of zeros or not because this is simply 0. So what I get finally, I can rewrite it like only simply 23.3. They both are same, 23.3 or 23.0. So what I will do, 23.3 plus this quantity 0.23535 and so on. So again we can do the similar process. The left hand side quantity which we have now is 100x equals 23.3 and this is your x. So you can now easily solve this equation. For the variable x, we can easily solve this equation. So subtract x by taking it on the left hand side, you get 23.3. So 99x equals 23.3, which is simply 233 by 10. Take this 99 over here. So x will be 233 by 99 times 10. So this is 233 by 990. This is the required rational number corresponding to this decimal expansion. Now finally we are going to take the third problem. If you see now, in the third case, this decimal expansion which we have is terminating. So it's now quite easy to solve. That if I call it my x, 3.14268, you simply look at the decimal and collect like how many terms from the unit place towards from this to this direction you have to see. If you see now 1, 2, 3, 4, 5, 6, after 6 places your decimal is there. So what we will do, I will simply write this expression as it is and divide this quantity by 10 raised to the power 6. And if you can expand this That is, after 1 write 6 zeros. Fine. So this is your required P upon Q form, and it is the required rational numbers. So what we have understood in the today's lecture, that if we are given some decimal representation, so we can easily reduce the decimal representation, whether it's a terminating or non-terminating decimal representation. Of course, it should be a rational number. It cannot be an irrational number. Whatever the decimal representations which we have learned today are based on for the corresponding rational numbers. So we can reduce them in the form of fractions p by rational numbers easily. So we can easily reduce them in the form of ratio of two integers, which is for the rational number. And one more, just a remark at the last I would like to give today. In the first case, this was our decimal representation. Only one digit was repeating here. So I can rewrite it as 0.3, this bar over that digit which repeats. So likewise in the second case, you can write it as this one, and in the third case there is no repetition of digits, so it is as it is. So we have covered the today's lecture. In the coming lecture, we're going to learn how to find irrational numbers between two rational numbers, and of course the last important topic of chapter, operations on real numbers. Find some relevant links in the description, and do share about our initiative, subscribe the channel. Thanks so much for watching.